Hello everyone. We have studied the Gauss theorem last time to find the electric field due to various types of symmetric surfaces. Today we'll see another new topic, that is electrostatic potential. Now this electrostatic potential term comes from the term potential energy. Potential energy for a positive charge. Let us consider the expression for electrostatic potential. Here there is a source charge plus Q. Consider a point P where we have to find the electrostatic potential. So according to the definition of electrostatic potential, it is the amount of work done to bring a unit positive charge from infinity to a given point. So to find the work done, consider a unit positive charge or test charge, and we are bringing it from infinity to the point. So from infinity to this point, consider two points A and B. Let the small distance covered from A to B be dx. Let this point A be at a distance x from the source charge. Then the test charge is here. The test charge is having a positive sign, unit positive charge, and the source charge here, source charge, it is having also the positive sign. So therefore on this particular charge the force is away from the source charge. Since we are bringing it near the source charge, this test charge is brought near the source charge. So we have to do work against the electrostatic force of repulsion. The force is acting in this direction. We are bringing it towards the source charge. Therefore, the work done in that case can be written as dW, small work done, and we are moving it from A to B. So the formula will be F into dx, where dx is the distance between A and B. Now we have placed the charge, test charge Q naught at point A. So according to Coulomb's law, the formula is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. The same formula we have to apply here. But the only thing is the force and displacement are opposite. Force is upward and displacement is towards the source charge. So we write minus sign here and then we substitute the value. So 1 upon 4 pi epsilon naught Q, that is the source charge, into Q naught, that is the test charge, upon x square. X is the distance from the source charge to the point A, into dx. This is the small work done in moving from A to B. Now, since we have to find out the total work done, and according to our definition, we have to take the limits from infinity to the given point. So, in that case, we will find out by integrating this expression. So, our formula becomes minus 1 upon 4 pi epsilon naught Q into Q naught integration of 1 upon x square dx from infinity to r. Ultimately, we have to come to point P, which is at a distance r. So I have taken the upper limit, lower limit as infinity and upper limit as r. Now I have to find out the integration of 1 upon x square. So I can write it as x raised to minus 2 into dx. So we can write the step like this: q naught 1 upon 4 pi epsilon x raised to minus 2 into dx. X raised to minus 2, you have to remember the formula x raised to n dx. In the integration we have studied x raised to n. The formula is x raised to n plus 1 upon n plus 1. So here it will be x raised to minus 2 plus 1 upon minus 2 plus 1. So minus 2 plus 1 is minus 1. So we can get here the integration as x raised to minus 1 upon minus 1. X raised to minus 1 upon minus 1. Upper limit and lower limit from infinity to r. From infinity to r. And this minus 1 upon 4 pi epsilon naught q naught outside the bracket. Now here if you simplify this, then we will get minus q into q naught upon 4 pi epsilon naught. This minus sign we can take outside, so this becomes plus, and 1 upon x. Now we will put the limits. This is a definite integral. So now we will get q naught upon 4 pi epsilon naught. Upper limit is 1 upon r minus 1 upon infinity. Now 1 upon infinity, as you know, it is 0. So our formula comes out to be, this is integration of this side. So we will get here W as the work done after integration. We will get the whole work done as W. So what is the formula finally we are getting? That formula is W is equal to Q into Q naught upon 4 pi epsilon naught into R. So we can write this as W upon Q naught. If I write W upon Q naught, then I will get the formula as, so I am writing the final formula after dividing this W by Q naught. So W upon Q naught. If I divide, then I will get only 1 upon Q upon 4 pi epsilon naught into R. Or I can write it as 1 upon 4 pi epsilon naught Q upon R. Q upon R. So I have found out the expression W upon Q naught 1 upon 4 pi epsilon naught Q upon R. Now this is called as the electrostatic potential. What is electrostatic potential? It is work done per unit charge and it is having a symbol V. So V I can write as 1 upon 4 pi epsilon naught Q upon R. Okay, so this is the formula for the electrostatic potential. Electrostatic potential at the point P. At this point the potential is 1 upon 4 pi epsilon naught Q upon R. You have to remember that in case of force, the formula is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So F is inversely proportional to R square. In case of electric field, it is again inversely proportional to R square. 1 by 4 pi epsilon naught Q by R square. In case of V, it is not the inverse square formula, but it is only having the inverse proportion. That is, V is inversely proportional to R. Not R square but R. So this is the point which you have to remember in this case.